So what I was discussing is the helical reinforcement, that is that goes like this. Now this helical reinforcement should be between bars, 6 bars minimum, wrapped around 6 bars. There will be bars like this. Then in helically reinforced column, the longitudinal bar shall be in contact with the helical reinforcement and equidistant around its inner circumference. It should be equidistant. All the bars should be equidistant from each other throughout the circumference. They should not be एक और दूसरे बार के बीच में spacing कहीं पर 100 mm की है and then you are increasing it to 200 mm. That should not happen. Then spacing of the longitudinal bars measured along the periphery of the column shall not exceed 300 mm. Now, the spacing between these bars, whether in the rectangular bar or this is a rectangular here, this should not increase greater than 300, maximum 300 mm. But there is also a limit to the minimum spacing between the bars. Probably is 75. Let me check. Not given here. You have to maintain at least 75 mm minimum spacing between bars. Minimum is 75 that one has to maintain between longitudinal bars, and maximum spacing is 300 mm between the bars, whether it be rectangular or circular. In case of pedestals in which the longitudinal reinforcement is not taken into account in strength, nominal longitudinal reinforcement shall not less than 0.1% shall be provided. When you have a pedestal, which I told you last time, which is even less than a short column, something like this, which has LBD around 3, in that case, the longitudinal bars is not 0.8% that you provide, it's only 0.15% that you provide, 0.15%. Thereby, a pedestal is a compression with effective length which does not exceed 3 times the least lateral dimension. Now, next comes, after the longitudinal bar, comes the transverse reinforcement. Now, how is the transverse reinforcement provided? This was about the longitudinal. B part is the transverse reinforcement. How do we provide it? First of all, what is the purpose of transverse reinforcement? I told you that last time, that number one, it confines the column. Number two, the transverse reinforcement prevents the buckling of the column. Number three, it stops the local buckling, which may happen at any point. There could be a global buckling, which could happen somewhat like this. Global buckling, I mean by global buckling, a buckling which is happening like this. For example, like this, throughout the column, there is some amount of buckling happening. Local buckling would mean there is a portion of this is buckling out. And that usually happens when the longitudinal bar begins to yield at some point. If there is a longitudinal bar here, that may yield at this point. If that happens, there is a local buckling happening in the column. So transverse reinforcement also prevents the local buckling happening. Other role could be that it offers some amount of shear resistance. Now, how do we provide the transverse reinforcement? A reinforced concrete compression member shall have transverse or helical reinforcement so disposed that every longitudinal bar nearest to the compression face has effective lateral support against buckling, subjected to provisions in B, which are provided next. The effective lateral support is given by transverse reinforcement, either in the form of circular ring, capable of taking circumferential tension, or by polygonal links, lateral ties with internal angles not exceeding 135 degree. The ends of the transverse reinforcement shall be properly anchored C 26.2.2.4 B. So first, let me go to this. This is how the transverse reinforcements are could be provided. These are in advanced cases. But for simple cases, how do we provide the transverse reinforcement? For example, you have a column like this. In this column, this is a column I have just provided. Now, this could be a simple case when you have 4 bars here, and the total width of this column from here up till this point, from this point to this point, and also on this side, it's around 300 mm. Why 300 mm? Because the maximum spacing between the longitudinal bars is 300 mm. So then the spacing would here would be less than 300 mm. So if this is a case, it's less 300 mm by 300 mm, for example, the transverse bars could be provided as a single ring. It could be provided as a single ring, but with a hook at the end. This transverse reinforcement is being provided as a single ring with a hook at the end. Then this hook would have an angle of, this is the hook, and about this, there is a bend. This bend here is, if you project it, not able to depict it. This bend would be, or I can show it like this. This bend is 135 degrees. It's 135-degree bend. Similarly, in the opposite plane as well, when you are providing the other like this one, it's also at 135 degree. So the hook is to be provided at 135 degree. This is for a simple case. Now, when you have a column whose one side is greater than the other side, and before going into this, let me first show if again the two sides are equal, and now you have at least 3 bars on each side, for example, then when do we provide at least 3 bars on each side? When this is now greater than 300 mm. Similarly, when this is greater than 300 mm, then you are providing at least 3 bars. Now, how do we provide the cross ties in this case, or the rings in this case? Either we can do like this. This is one form of doing it. You are providing 2 separate rings this one and this one, and they're overlapping over the middle one. Either you do this, or what we do is that we may provide a single over ring like this, and then we could go for a cross tie here. Its hook would be like this, and the overall hook would be here. So this is the other way of doing it. Similarly, in this direction, you would have a lateral tie in this fashion. What happens to the hooks along the length of the column? If this is the column, if you're providing one hook of a tie, there's a tie here, then there is another tie here. There will be spacing between the ties. They are these ties are connecting the longitudinal bars. The, these ties or these rings or these transverse reinforcements are connecting the longitudinal bars. Now, in first hook, in first tie, the hook will be somewhere here, and in the second case, it will be somewhere here. Means, अगर आप इसको first the hook will be here, then it would be here, then it could be in the third one, it could be here, and in the fourth one, it could be here. Similarly, again in the fifth one, it would be at this point. Sixth one, it would be here. Seventh one, it could be here. Eighth one, it could be here. So you alter the position of the hooks such that even when you have loading, lateral loading, because during earthquakes, the load will be like this and this, it could be this and this. In that case, the rings do not open up. There is a hook at different positions throughout the length of the column. Next, if you have the column like this, not like this, and like this, in that case, when you have one side much greater than the other side, now you have a lot of options like you have been given here in this code. One side is quite large and the other side is quite less. And the spacing is around 75 between the bars here. In that case, there are two rings. एक ring ये जा रहा है, this one, and then the second one is overlapping like this. So the middle one is being overlapped twice. In this case, similarly, if you have 48 times 5 TR, less than 48 times 5 TR, one side greater than the other, then you could provide two lateral ties or cross ties. These are known as cross ties or lateral ties. There are two. This is hook, sorry, this is ring, and these are cross ties. Then you could have a case like this when you have this is a big column. You have the spacing around 3 times phi. Phi is the diameter of the longitudinal bar. That would mean around, for example, if that is 32 mm ka bar, then it's around 90 here. So greater than 90 mm even here. In that case, you would have to provide, you could provide an outer bundle and an inner bundle of the columns, these longitudinal bars, and they are connected in this fashion. So there you have one ties here like this, and the other one is in this fashion, two ties there. Similarly, you could bundle the longitudinal bars at the ends. Then you have an outer ring first throughout, and then small rings connecting the bundle, individual groups. If you have a large load and a big column, then this is done. Usually, no longitudinal reinforcement is provided at the center. You will not find, you will see that it's kept at the center portion is usually kept to be open. And this is again done for the compaction purposes such that the compaction happens properly. So this was about the how do we place the longitudinal transverse bars. Then what is the, if this is the arrangement that's given here, I have already explained to you this. Now what is the pitch and the diameter of the lateral tie? The pitch of the transverse reinforcement shall not be not more than the least for the following. The least lateral dimension of the compression member, 16 times the smallest diameter of the longitudinal bar, or 300 mm. So it's written that the what is the pitch first of all? Pitch is the spacing between, this is a column, and you have these as rings. Now what is the spacing between these rings? This to this space. What is the spacing between the rings? That's known as pitch. And that's provided as, how do we provide the pitch? It's 300 mm maximum, or it is the least lateral dimension of compression member. Least lateral dimension, least, that's D. If you are taking W is the larger one, and then D is the smaller one. So, the depth or the and the width of the column. So either that, or you take 16 times the smaller diameter of the longitudinal bars. The dia of longitudinal bars, 16 times the diameter of the longitudinal bars. Which one? The least dia. It's taken from the least dia. That's the smallest longitudinal bar. These longitudinal bars could be different sizes. This could be, say, 8 mm, sorry, 12 mm. This could be 14 mm. This could be 16. This could be 20 mm. So we take the least of the least dia, उसका 16 times. तो इन तीनों में से जो सबसे कम आता है, the least of all these three, the least of all these three, that is taken as the spacing or pitch of the transverse reinforcement. Now, then there is also diameter of the polygonal links or the lateral tie shall not be less than 1/4 of the diameter of the largest longitudinal bar, and in no case less than 16 mm. So then comes the question of what is the diameter? Diameter of the longitudinal bar, we already discussed, that has to be minimum 12 mm. What is the diameter of the transverse bar? That has to be at least First of all, we usually take not less than 8 mm. 6 mm was taken earlier, but we usually do not take less than 8 mm diameter. Uh, Sorry, 16 mm in case of columns. 16 mm, it should be 8 mm. This is wrong. This is, and in no case less than 16 mm is wrong. You cannot have links. There is a change in this code. It's 8 mm at least, and the diameter shall not be 1/4 of the diameter of the, or 1/4 of the diameter of the longitudinal bars. So, for example, you have 32 mm bar, then that would mean around 8 mm. 1/4 of that would mean 8 mm. So, if you have a bar greater than that, but at least you have to provide 8 mm the diameter of the ties. Then, in case of circular columns, you have a pitch for a helical reinforcement. Now, which turns shall be the regular formulation with the turns of the helix placed evenly, and its end shall be anchored properly by providing 1.5 extra turn of the spiral bar. Where an increased load on the column on the strength of the helical reinforcement is allowed for the pitch of the helical shall not be less than 75 mm, not more than 1/6 of the core diameter of the, not less than 25 mm, not less than 3 times the diameter of the steel bar. So the diameter of the helical bar should be as per this as well. So it has to be 8 mm at least. And how do we provide the pitch there? In helical reinforcement, this is the helical reinforcement. You have from this point onwards, it will, there is a turn, and it again reaches to that point. So till this point, you will call it one pitch. Similarly, this has to be like this actually. And then like this. So the pitch will keep on being taken from this point up till this point, or you can even take from any point like this, but at the same position in the other one like this. So it becomes a one pitch. And what is the minimum pitch that you take? Minimum pitch that you take is 75 mm, and the maximum is again 300 mm. You do not exceed. Minimum is 75 and maximum is 300. Even in the case of uh, these lateral ties, when you are providing not as helical reinforcement but as lateral ties, here even you do not keep the spacing less than 75 mm. The spacing has to be around 75 mm. But as per IS 456, you usually keep the minimum as 150 mm. As per IS 456, जो क्या हम अभी यूज कर रहे हैं. But if you go to the earthquake code later on, 75 mm is recommended as per IS 1893 as per the earthquake code. The minimum pitch or the minimum spacing between the lateral ties. So then you have, so that's all about the steps of design here up till this point. Next we'll take up a design question on this.